Go. So we're deriving tangent inverse of x plus 2 square root of x. I would rewrite this guy as 2x to the 1/2. Let's do a quick reminder on the tangent derivative. So deriving with respect to x of tangent inverse, and I'm going to use u. You can use x if you want. That is 1 over 1 plus u squared times the derivative of that u. So if I were to mimic this, instead of u, we have x. So I will write out 1 over what? We're just matching. 1 plus x squared, and then times what?
2.
What's the derivative of that x? 1. And then we have plus, let's recall derivative with the power rule. We take the power and multiply by the coefficient, which is 1. And 1 less of 1/2 is how many? Negative 1/2. And notice that negative 1/2 is technically on the bottom. So if I were to simplify this, we have that understood 1, so I kind of don't need that, plus 1 over square root of x. They mean the exact same thing. So then what will be our answer choice? E.
Wait, where'd you get 1x from?
1x. What is this times this?
Okay.
Okay, now let's go on to number 20. On number 20 says to derive how many times? 4 times. So let's derive it first time. This one is chain rule. So I bring the 4 down, keep the inside. 1 less of 4 is how many? 3 times the derivative of the inside, which is 2. Now I want to simplify this before actually deriving again. I have my 2 constants that I can multiply. That's going to give me 8 of the inside to the 3rd. Deriving that will be easier. So we have f double prime. So 3 times 8 is how many? 24. We keep the inside. And 1 less of the 3 is 2 times the derivative of the inside, 2. Let's multiply the constants again. That's going to give us how many? 48. Keep the inside with the same power. Okay, what is 2 times 48? 96. Was it 96? Oh, yeah, 96. Oh, 3rd derivative. And then we keep the inside. And 1 less of that power is basically understood 1 that I don't really need to write. But if you want to, you may. Again, still times what? 2. So let's multiply the constants. How many? 190. Ooh, I see 192. 2x plus 1. And then at this point, all I need to do is derive that inside by itself. So our 4th derivative. It is 192 multiplied by the derivative of the inside, which is 2. That's going to give us 384. So even though it says to plug in 0 for the x, I don't have an x. So the only thing is 384, which is E. Okay, 21 and 22 looks very similar. Because both of them, the particle is at rest. All right, Sullivan, let's read number 21.
A particle moves along the x-axis so that its position at time t is given by x of t equals t squared minus 6t plus 5. For what value of t is the velocity of the particle 0?
So we have position, and I want the velocity of the particle to be 0. So let's do a little recap. Position is f. Velocity is f prime. Do we all see that? So in this case, that means, first of all, when something is at rest, that means our slope is 0. So we know our velocity is equal to x prime of t, and that's got to equal 0. So we do need to derive this just one time. X prime of t. The derivative of this one is 2t and what? Minus 6. And now let's plug in the 0 into this whole thing as 0. So 0 is equal to 2t minus 6. And then you're going to apply algebra 1. That's going to give us t is equal to 3. And that's it. All right, Will, let's read number 22.
A particle moves along the x-axis so that time greater than 0 is position given by x of t equals 2t to the third minus 21t to the second plus 72t minus 53. At what time t is the particle at rest?
Okay, we have another rest, so slope is equal to 0. And just like I said, the velocity is the position derivative. So we're going to derive this just one time. So when I derive this, we get 6 what? T squared minus? Plus? And I'm going to set this whole thing equal to 0. So while I'm at it, let's go ahead and take out our GCF of 6. T squared minus 7t plus 12. And when I do my factoring, what two numbers will satisfy the negative 7 and 12? Negative 3, negative 4. So that means our actual t values are 3 and positive 4. And where do I have 3 and 4? And then we have our Fuigi. All right, Karis, let's read number 23.
The radius of the right circular cylinder is increasing at a rate of 2 units per second. The height of the cylinder is decreasing at a rate of 5 units per second. Which of the following expressions gives the rate at which the volume of the cylinder is changing with respect to time in terms of the radius r and the height h of the cylinder? The volume v of the cylinder with radius r and the height h is v equals pi r squared h.
So they're asking us which of the following is a volume changing. So we know we're finding dv over dt. They gave us two given rates. They said the radius is changing at 2 units per second. So we know dr over dt is 2 units per second. And they also said the height is changing as something. The height is decreasing. If it is decreasing, what number do I need? So we have dh over dt is equal to negative 5 units per second. And we know the equation is given, volume is pi r squared h. So then, we have two variables in this equation. We have variable with the r, pi is not a variable, h is a variable, so we're using product rule. So we have dv over dt is equal to, when I derive pi r squared, 2 comes down with the pi and r. Because I derived something with the r, we have to add in dr over what? Good, dr over dt. Plus, and then now I keep the original pi r squared as it is. Derivative of h is simply 1, but I also need what? dh over dt. So let's plug in everything that I know. Did they give us when the radius is something? So we have 2. We have, oh, it's going to be in terms of the radius, okay. Pi r. And we know dr over dt is how many? 2. Did y'all realize I forgot to keep the h on the other one? I derived that and I'm supposed to keep the h. Oops. And then there's my h. Plus pi r squared, and we know dh over dt is negative 5. And when I simplify that, we know that 2 times 2 is going to give me 4. Meaning it's not going to be A, not going to be B. And we also know the other rate is negative, has to be C. All right, let's move on to number 4. For number 4, the first thing that we have to do when a limit is reaching a number, what do? Plug it in. Hopefully when you plug in the 0, you know the top is going to be 0 over 0. Do I need to show that part? We're good? Okay. When it's 0 over 0, we have L'Hopital's rule, which states derive the top independently and derive the bottom independently. So we have limit as x approaches 0, the top derivative of e to the x itself times the derivative of the power, which is 1 that I'm not going to write. Derivative of negative 1 is 0. What's the derivative of the bottom? 1. Now let's plug in the 0 into the remaining x. E to the 0 over 1. What is e to the 0? 1 over 1 is? Done. Okay, I want you to plug in the 0 for the next one. And I'm hoping you'll get 0 over 0. Do we get 0 over 0? Okay, so let's use L'Hopital's rule. So we're deriving the top independently and bottom independently. So we get on the top 6 e to that itself times the derivative of the power, which is 4, minus 2 e to that itself times the derivative of that is how many? 3. And then do I need to derive the negative 4? Nope. On the bottom, we have chain rule. What is the derivative of sine? Cosine, and you keep the inside, and then you multiply by the derivative, which is 2. So now let's plug in the zeros into the remaining. We have 6 e to the power of 0 times 4 minus 2 e to the power of 0 times 3 divided by, let's kind of think about what's happening to cosine. It is cosine of 0 times 2. What is the value of cosine of 0? 1, very good. So I'm going to write 1 times 2. And isn't e to the 0 1? Yeah? So it doesn't change anything. So we have 6 times 4 is going to be 24. 2 times 3 is minus 6. If I simplify that, that's going to give me 18 over 2. What is 18 over 2? Done. Okay, we got 2 more. Jason, let's read number 26.
The graph of f prime, derivative of the function f is shown above. Which of the following statements is true about f?
F prime? Oh yeah, about f, correct. It's given f prime. So I'm going to go ahead and write out everything above is positive. Everything below is negative. So it wants to know about the f. So looking at this, only given positive and negative. I could say the function is increasing because f prime is what? Positive. Or the function is decreasing because f prime is negative. Look at choice B. Is that true or false? I'm just going to stick with that and move on. Okay, Jacqueline, our last one, number 27.
The first and second derivatives of the function f have the properties given in the table below. Which of the following could be the graph of f?
Okay, so let's analyze all parts of it. If f prime is negative, that means my graph is going down. If it is positive, it's going up, and then we have a negative going down. If double prime is negative, it's concave what? Down. So concave down here again, and down and up. If there's not a derivative, but we know it's continuous, there must be a cusp right here. So let's analyze. The graph is going to start by concaving down. So this one is concaving down. This one is concaving down. So I know I can eliminate these two answers. I guess this is also concaving down. I take that back. Okay? But then we also know at the end it's going to concave up. So we know from here it's concave up here, that it's not concave up. And my last part, the only difference here, if you kind of noticed, 2, 3, and 4 is concave down. 2, 3, and 4 is concave up. So which one is going to be our best answer according to our 2 to 4 domain? B it is.